Hey, what's going on, guys? In this video we are going to see how to prove this proposition. This proposition says for all x comma y belongs to integer, if x is odd and x plus y is even, then y is odd. Now let's see how to prove this one. First we are going to assume x is odd and x plus y is even, as it mentioned in the proposition. Assume x is first we have to say let x comma y belongs to integer, as it mentioned in the proposition. Assume x is odd and x plus y is even. Okay, first we are going to give a general expression, then we are going to say then there exists a k belongs to integer such that x is equal to 2k plus 1. Here what we are saying is x is an odd number, because if you multiply an integer by 2 and add 1 to that, it's definitely an odd number. Okay, that's why we express like this. The next thing is we are going to express x plus y is an even. To express this one we are going to say and there exists a k such that it belongs to integer such that x plus y is equal to 2k. If you multiply any integer by 2, it's definitely going to be an even number. That's why we express like this. Okay, now here we are going to use two different terms for x and x plus y. Now let's see what is that. We are going to say the same thing, but we are going to use two different way, a b kind of things. Okay, let's go ahead and do that. Let a belongs to integer, okay, and with x is equal to 2a plus 1. I did the same thing like this. I just changed the variable into a. Now here instead of 2k we are going to put 2b. Okay, and let b belongs to an integer with x plus y is equal to 2b. Okay, now after that put c is equal to b minus a minus 1, because we are going to replace later. As I do, you will see that. Then y is equal to x plus y minus x, that's equal to 2b. Okay, x plus y minus x, that's equal to 2b. Now x plus y, as we mentioned here, it's equal to 2b. Here we wrote the equation for y, because if you subtract the x from x plus y, you will get y, right? That's why we wrote this one. Now x plus y is equal to 2b, that's why I put it right here, and x is equal to 2a plus 1 right here. So I subtract 2a plus 1 from this. Now instead of 1 we can say this is 2 minus 1 equal to 1. So 2b minus 2a plus 2 minus 1. I just expand 1 as 2 minus 1, because here what we are going to do is we are going to take 2 common. Now let's see what have. Okay, here I made a mistake. When I subtract, I put a bracket right here because this minus is going to be common. And if we expand this one, so this is wrong actually, because if we get this one out of the bracket, this is going to expand it as minus 1 right here. So to make this one into 2, because I'm going to take 2 common, to make this one into 2, to make this one into 2, I put minus 2. If I put minus 2, I had to put plus 1 right here, because it's supposed to be minus 1. We put 2 right here. If we put 2, we had to add 1 to that. Okay, now we got 2 everywhere. Now we can take 2 common. If we take 2 common, this is going to be b minus a minus 1 plus 1. That's the reason we put this c right here, because we are going to replace this b minus a minus 1 to c. In that way we will get 2c plus 1. So this is, you can see, we have multiplied by integer 2, it means it's even, this part is even, plus 1, it means it's odd. So we are getting y is odd. That's what we want to prove. Then y is odd. If x is odd and x plus y is even, then y is odd. This is our claim. We have to claim is the one that comes after then all the time. If we have an if then statement, it's always the one that comes after then. That's our claim. That's what we have to prove. Now here we proved y is equal to 2c plus 1. So we can say therefore there exists a c belongs to integer such that y is equal to 2c plus 1. That means y is an odd. Thus we can say thus y is odd. Finally we can conclude this one as therefore if x is odd and x plus y is even, then y is odd. Okay, and that's it. That's how we prove this proposition. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too. And don't forget to subscribe. See you next time.